Good morning. A little bit about S34, the applications and presentation layer. And I promised the ad hoc group chairs that I would not steal their thunder for this afternoon, so it's going to be a little bit high level, and I don't want any hard questions. Leave them for them, yeah. S34 is comprised of 5 groups, and actually I'm going to go in a different order than what you see here when I do the presentation, starting with S34-3, the Conceptual Models group, and then we'll talk about the video, audio, runtime, and accessibility groups in that order. So getting into S34-3, S34-3 was formed very much at the beginning after the S31 group completed its work on the requirements. And S34-3 was designed to put some meat on the bones of some of the requirements and provide enough information for real technical work to take place. Some of the requirements were at a very high level, and some of the requirements were very detailed. For the high level ones, the ad hoc group needed more information about where exactly to get started. And the documents that this group produced and are producing is the service conceptual model. This one is of great interest, and I'm actually going to spend a fair amount of time on these conceptual models because this is kind of the high-level view of what you can do from the consumer's point of view with the new system. The service conceptual model is kind of the core of the whole thing. What all services can I have? What components am I going to put together? And how are we going to assemble all these things at the viewer's receiver? They also provided a framework for advanced emergency alerting and personalization, service usage reporting, and companion devices. And as it says in the slide, this documentation is not going to go into a standard. This documentation was designed to be consumed by the other groups in ATSC 3.0. So a little bit about the service conceptual model. We have this great new system. We've got these different robust pipes. We want to do hybrid delivery. All sorts of stuff. So it sort of called into question, what is a service now? What kinds of services are now possible? How do things go together? How does it all work? This is the bulk and the meat of what S34-3 produced. So the first thing they did is, well, what kind of services can we have? Well, we do have linear services. We always have Watch TV. But let's think about how we're going to enhance those linear services. So the idea of having multiple components, not just more than one audio stream, but also more than one video stream, more than one closed caption track, perhaps some app-based enhancements and all sorts of stuff. There's also a strong demand for on-demand. I think we recognize that that's a consumer trend. So having the ability for broadcasters to provide an on-demand service was absolutely paramount. Interactive applications are definitely part of it, and there's kind of 2 parts of this. You can have an interactive application which rides along with your broadcast. So if you want to have a game show that plays along or additional news feeds or whatever like that that really is meant to be companion to the linear service, you can have that. But we also have a concept of a standalone app. And a standalone app might be something like Catch-Up TV, where you could launch this standalone quote-unquote app service, and the service pops up and it says, oh, we have Catch-Up TV, what would you like to watch that you missed? And then there's also the possibility, of course, of audio-only services. So a little bit about the components that go into these services, and the component types are kind of driven the formation of the ad hoc groups. So as you can imagine, there are audio, video, captions, and applications. And we also have this notion that we might have multiple alternative components. And there might be different ways to choose these things. So for example, maybe I'm going to have to pick just one. If I have an audio track, I probably don't want to listen to more than one audio track at the same time. So I'll pick one. Or maybe I'm going to pick more than one. Perhaps I have a picture-in-picture capability, so I'm going to have 2 video tracks playing at the same time. And in terms of making that selection, it's possible that the user could be selecting it. I want such and such of a language. Or it's possible that the device could be selecting it. So for example, if there's one track that it's capable of rendering and one that it's not, well, let's pick the one that we can render. That might be an example of having a scalable video codec, for example, where the receiver is capable of producing the HD content, but not capable of combining it with the UHD enhancement layer. So those would be the auto-selectable types. This wasn't actually in the service conceptual model, but I think it's important enough to include here, and thanks to those that pointed out to me that this isn't actually in the model, this delivery mechanism, since it's kind of the purview of S33, but nonetheless, I think it's a very important part of the concept of how you're going to be providing services in ATSC 3.0. So we certainly have the concept of broadcast-only services where all the signaling and all the components and everything comes through the terrestrial over-the-air broadcast. We also have this idea that there's hybrid services where you can combine broadcast and broadband to deliver a single service. So in this case, you might have some components coming over the broadcast and you might have some other components coming over the broadband. A good example for that might be you have quote-unquote long-tail components where you have perhaps an alternative language audio track that you know that a small portion but important portion of your viewers are interested in. So this one you might want to send via broadband rather than via broadcast. And the idea is that you can send all these things and the receiver is capable of understanding how to synchronize them, how to offer the choices to the viewer, and render the finished product to the viewer. There's also this concept of a broadband handoff capability. So the idea that there might be a period of time when you go into the tunnel or you drive out of range or something like that, and the broadcast signal has become weakened enough that the device is going to look for an alternative path to get all of its content. And that includes the signaling and all the components and everything. And of course, this is a broadcaster choice. Do you want to offer this type of capability? But if you do, the system is able to do that where you can have a complete handoff from broadcast to broadband, and then when the signal strength is strong again, to come back to the broadcast. One thing that I wanted to sort of add there is a small note, which that's actually a big enough screen, you guys probably can read it. There was a fair amount of discussion as to whether or not we're describing complete over-the-top services that have exactly zero to do with the terrestrial broadcast. Conclusion, no. If you want to do pure over-the-top services, that's not going to be part of an ATSC standard. But there's obviously ways to do that. So everything that we're specifying in the standard has an origination point in your terrestrial broadcast. So if you want to provide a service that has nothing to do with that, go for it, but you won't find help in the standard for that. So hybrid delivery, all these different ways of combining broadcast and broadband. So a little bit about the temporal. So I've sort of talked about the vertical stack of your service. You have components piled together and you put them into a single presentation. But you also have this linear concept of the service conceptual model, what's going on across time. And the service conceptual model talks about programs. You might have a show. So a program would be an airing. You're showing, I always use the same example because I'm old, not as old as everybody, but I'm old. So Seinfeld, the puffy shirt. I watched a lot of Seinfeld. The puffy shirt episode would be a show, and a program would be an airing of that show. So lots and lots of you might air Seinfeld, the puffy shirt episode, and that's the show, and it has a title and a description and actors and, you know, a date that it was produced and all that good stuff. But your program says, okay, it was aired on WXBC and at such and such of a time, and it had these interstitials in it, and it was divided into these segments. So that's your program compared to your show. So the program inherits aspects of the show when you would describe a program. And then, of course, you have the segments. So these are the portions of the show that are carved up, usually interspersed with interstitials. Interstitials can be ads, promos, pledge drives, and whatever else you want to put between the segments of your show. So all this stuff is in the service conceptual model. So just a little visual example. Here's your sort of component stack going vertically and your temporal going horizontally. In this illustration, you might have two program segments, one on the left and one on the right, and two interstitial segments in the middle. And in this case, you're offering all these different things. So in your program segments, you're actually offering two sets of closed captions and an interactive app in the first segment. In the second segment, you've got two audio tracks, two video tracks, and you've got some apps. In the interstitials, you just have one of each plus an app available in the second interstitial. So how are we going to do this from the presentation point of view? In fact, you may be delivering some of these by broadband. And the components are selected and combined at the receiver. So viewer number one may be watching these components now in black. And viewer number two may pick something completely different to look at. And that's sort of how the service conceptual model works. And you can use that to understand a little bit about what you can do with basic services. I'm not sure I should call them basic services anymore, but this is the new Watch TV. Okay, a little bit about video, again, just touching on these things. The details are coming in the afternoon. So with video, we definitely want to look at enhanced high definition. What do we mean by enhanced high definition? We may mean higher frame rate, we may mean wider color gamut, we may mean high dynamic range and all that stuff. Definitely want to have UHD key goal. And we're also obviously targeting large screens and small screens. In fact, one of the requirements that came from S-31 is that high definition must be enabled for the small screens at minimum and ultra high definition for the big screens at minimum. Certainly looking at the new latest and greatest state-of-the-art codecs, getting a huge benefit there. And also, as I mentioned, the multiple selectable components, 3D support, of course. There's scalable coding, which is in consideration, and I know Alan's going to go into that in more depth in the afternoon, and lots more to come. So just a few things here on this slide, and again, I don't want to spend time on it. This is just your basics here, and you'll get a lot more in the afternoon, but a little bit about the resolution, some of the general agreements that have already taken place, some of the things that are still in discussion, and it sort of goes on from there. So audio. There are sort of two big buckets to think about in terms of improvements in the world of audio for ATSC 3.0. The one bucket is the sound itself, and the idea of having immersive sound where you're not only getting sound from a point of one speaker or 2 points of 2 speakers or surround sound from speakers around you, but the idea of having 3D sound, so you could have speakers or sound coming from the ceiling all the way to the floor, and so you sort of get this surround sound aspect to it. Believe it or not, this translates into headphones. You guys are going to be in for a treat in July when you see the audio codecs and demonstrations on demo day. It is quite impressive. So in addition to the increased sense of sound envelopment, we're certainly targeting all the different devices, different speaker setups and headphones. Jim is going to have a big challenge fitting his presentation into 20 minutes. We'll see how he does. But when I say lots more, I really mean lots and lots and lots more in the audio sessions in the afternoon. The other major aspect of audio which is coming, which is pretty exciting, is this idea of personalization. The idea that you as a viewer and you as a broadcaster can offer your viewer the capability of enhancing your audio experience in different ways that you want. So you want the dialogue to be higher, you want the dialogue to be lower. You're a Boston fan for Bruins, like you all are in this room, I'm sure, and you want to hear those announcers versus the silly LA Kings announcers or something like that. Sorry, Bill. So you might have alternate tracks, special commentary, and then of course there's normalization of loudness and contouring of the dynamic range. But I'll let Jim give you all the gory details. A little bit about the progress here. Their call for proposals was issued. The call for proposals is highly, 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 highly detailed. And thanks very much to all of the audio folks, and in particular to the test coordinators, Skip Peasy from NAB and Paul Thompson from CEA, and to those two organizations for their support in this process, which has been absolutely indispensable. We have 2 proposals that are currently under consideration, and the proponents are busily executing the highly, highly, highly detailed CFP process. Full test results coming soon, so pretty excited about that. Okay, so moving on to the runtime environment, interactivity. What else can you do with your services? You can have interactivity either, as I mentioned, as part of your linear service meant to go with it, or as a service in and of itself. And it will have, we're working on the runtime environment with HTML5 support. And it's going to be based on HBBTV 2.0. And of course, as whenever you refer to another standard, there's restrictions and extensions. And And the extensions, we asked for people to please submit extensions that they wanted. Be careful what you ask for. So anyways, we have lots and lots to work on. The changes are being documented, and Bill is going to explain more about that in the afternoon, Bill Foote from Samsung. A little bit about profiles, and this is something that I want to bring specifically to everyone's attention in this room who may not be following all the work, because sometimes you think to yourself, well, if I was going to get involved in ATSC 3.0, I'm not going to attend every meeting under the sun. But there are certain areas that affect you that you might want to consider and find a way to get your opinion heard within the ATSC groups without necessarily attending every meeting, which, as I know from personal experience, takes a lot of time. So the profile thing is something that's important. The concept that not every ATSC 3.0 receiver is going to be able to do everything that the runtime environment specifies. So for example, if the runtime environment has an API to a DVR capability, well, not every TV has a DVR in it. So not every TV is going to implement that API. So when you extend that to all the different things that you might be able to do with an interactive television, and you realize, well, maybe manufacturer A is going to build a suite of products, and some products are going to be able to do these things, and others are going to be able to do those things, and different manufacturers making different choices, you as an app developer might be faced with such a fragmented world that you don't know what to put into your app, because you don't know which TV sets are actually going to be able to run the thing. So this concept of profiles and saying, okay, well, if you're going to build a TV that does interactivity, it should at least do this. So that we as broadcasters can count on the fact that all TVs that claim to do interactivity can at least do this set of things. And this is what we're calling the universal profile. There may be more than one. So for example, you might have a set of things that a 85-inch TV can do, and a different core set of things that a small handheld thing can do. So for example, if you have an API into a touch screen, you probably want that in the profile of the small screen, but probably not so useful on the big screen. The idea that, and the reason I'm bringing this to your attention is because if there are aspects of interactivity that you need enabled, where you would literally look at a CE manufacturer and say, you know what, if your device can't do this for interactivity, don't bother building interactivity into your device. These are the kinds of things that need to go into the universal profile, and if you have opinions and thoughts about this, now is the time to make them known. My email is at the end of this deck, so feel free. And I'll give you Bill Foote's home telephone number for other discussion, right? So the idea behind these profiles is to make a less fragmented marketplace so that we can have adoption. That's the main thing. And also to simplify implementations, keep the test vectors low, and like that. One thing that I want to point out on this slide is that we're working very closely with CEA on this project. Ultimately, it's going to be CEA who finally makes the definition of what these profiles are, but the agreed upon process at this point is that ATSC will recommend to CEA what we really think is the right thing to do. So that's where the strongest broadcaster voice can be heard, and also the people working on the actual normative text, who are CE guys, have a sense of what is reasonable and makes most sense, so we can offer that to CEA as a recommendation. So what can you do? Well, I hear a lot about targeted ad insertion. That would be nice. You might have an on-demand content launcher. This could be your catch-up TV. You can do screen mashups. Put your favorite NASCAR driver dashboard cam in the upper corner or something like that. T-commerce, voting and polling, news and sports, notifications, all that sort of thing. The idea is to give you a rich runtime environment that's, that you can write apps to. One of the things also that I want to mention about this is that the reason why we chose to base this on HBBTV is that there's actually a fairly rich environment and ecosystem around HBBTV right now. So if you're looking for an app developer, there are app developers who are familiar with HBBTV who we hope, working with ATSC 3.0, would not be such a great leap that they would have to start from scratch. In fact, perhaps some of their ready-made apps could be ported into your use cases. So that's part of the reason why we wanted to do that. It's about making it easy for the marketplace to adopt the technology. Accessibility. So you might have seen the bullet on the video slide that says we're not necessarily putting closed captions in video anymore. And so what happened is that recently, I think it was about, I want to say two months ago or 6 weeks ago, we broke this into its own ad hoc group, S34-5. I also want to mention that ATSC 3.0 has been considering accessibility from the beginning. It was in all of the requirements that were developed, as Skip mentioned, going back 2, 3, 5 years. And it was in the video group for quite some time, going under the sort of basic assumption that we're going to do it the way we used to do it. And it didn't get very much attention from the video group, and I think it came from S35, which was sort of working on the overall ecosystem, that said, captions is its own essence. We don't need to put it in video anymore. So immediately we pulled it out of the video group, created a new ad hoc group, and I'm absolutely delighted. We've got 40-ish people who are experts across the industry, from vendors to CE guys to accessibility advocates and all around. So it's an excellent group. It was formed a little bit on the late side, and we very, 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 very much want to get a candidate standard out by the end of the summer. So with this group, we're absolutely focusing on closed captions first, which is not to say that other aspects of accessibility aren't important. The goal is to get closed captions done as soon as possible, and we may do it in more than one tranche, where we do something fairly, I don't want to say straightforward, but something that can be done within that time frame, and then continue our work beyond that. So these are things that are all in discussion within that group, and Chris Homer will give you more information on that in the afternoon. And one thing before I take any questions, if there are any, is I want to offer my sincere thanks to the leadership in S34. Brett Jenkins is the vice chair of S34. We have Alan Stein, who is chair of S34-1, and John Fairhurst, who is vice chair of S34-1. Those guys are putting in a huge amount of work. On the audio side, we have Jim Starzinski, who is the chair, and Yeshwant Muthuswamy, who is the vice chair. And on S34-3, we have Giri Manjum and Sejin O leading that group. S34-4 is Bill Foote and Mark Iyer, and S34-5 is Chris Homer and Kiran Mishra. So I really want to take a minute to thank all those folks, because the amount of effort that goes into this is pretty amazing. And not to mention the companies that are behind those folks that enabled all this to happen. So, okay, now I'm done. Thanks.